Today we're going to be talking about dehumidifiers, and we're going to do a couple of things. The first one is we're going to compare this super old dehumidifier to these more modern units. This one right here is kind of a higher end unit made by Cooper and Hunter. This is kind of a more average unit that we picked up from Walmart. It's an Arctic King. These obviously have different capacities that they are able to produce, being that this one is so much bigger. One cool thing about this unit, it actually has a discharge pump, so you can pump the water away from the unit and up into a drain somewhere else if needed. But anyway, we're going to analyze the energy usage that it takes to operate these things, and then how much water they produce for each unit of energy. And also, you'll be able to decide whether or not you should unplug that old dinosaur dehumidifier that you have in your house, or if you should just leave it plugged in because it's almost as good as the new ones. The second thing we're going to talk about are the best humidity levels that you should be trying to reach in the thermal envelope or in your house to minimize mold and bacteria and just maintain the highest quality air possible. Oh, there's one more. Hold on. This particular unit is a 60 pint per day unit. You can see physically that these units are very different in size. This unit is physically smaller, and with that, it also has a lower output of only 20 pints per day compared to the 60 pints per day. And finally, the star of the show is this Amana dehumidifier that I stole from my brother's place. Link to his channel right here. You should go watch one of his videos so that hopefully he can upgrade his dehumidifier someday. But he said we could borrow this. It's been working fine. He said he thinks the previous owner before the previous owner bought this, perhaps, and this actually survived him. So we're gonna just see what kind of energy it takes to run this old dehumidifier compared to the new ones. Now this has the style of evaporator that I'm sure many of you guys have seen before, where it's just the exposed tubes and there's no fins really attached to the tubes. The water actually accumulates onto the tubes themselves, and then it drips off the tubes and then down into this collector pan down here. The minimum operating temperature is 41 degrees and we're just barely above that. So we should be good to go. Plug 1 is going to have our Cooper and Hunter dehumidifier plugged into it. Plug 2 is going to have just our standard Arctic King dehumidifier plugged in. And then plug 3 is going to have our classic Amana dehumidifier. This feels totally like wrong. Like this was manufactured, like Thomas Edison himself made this. And now we're plugging it into this brand new power strip. This thing will actually keep track of exactly how much power was used in each different position here. Once the test is complete, we'll be able to see how much power each have used, and we'll be able to compare that to how much water they produced. I will link to this power adapter in the description. This particular one requires Wi-Fi in order to set it up and monitor it, but you can control everything remotely with this particular power strip. So we'll go ahead and turn on our old dog first. Turn on the Cooper and Hunter. So it has power. And we'll turn on this third one here. Now for our old dehumidifier, we'll go to energy, 234 watts. Let's go to our Cooper and Hunter now, and 325 watts. The Arctic King, we'll check that one quick, and that one is using 224 watts. So our big dehumidifier is using about 100 watts more than the other ones. We have these set up so that the airflow should not be interfering with each other. The other thing we did is turned off turbo on both this one and this one, since that one doesn't appear to have a turbo mode, or maybe it's just always in turbo mode, I don't know. So we're gonna go ahead and let these things operate. If these things do fill up all the way, they'll just shut themselves off. We do have them set to continuous mode, so they should continue to operate even if the humidity drops significantly. Even this one has a continuous mode. For those of you who don't already know, a dehumidifier is basically an air conditioner where the evaporator and the condenser are located in the same unit. Normally you would have your A coil or evaporator or the head of your mini split unit inside, and then you would have a condenser located outside. This is all in one place. So what happens is humid air comes into the unit and it hits that evaporator that's really cold and it's below the dew point of the air. The humidity drops out of the air onto the coil, runs down and is collected in the bucket. Then that same air that's been cooled and dehumidified goes back through the condenser coil where it heats the air back up again. It really is just leaving the heat in the same space instead of actually removing it to the outside. And that's one of the reasons why a lot of the time you can get by with just using an air conditioner and manage your humidity levels pretty well in a typical home. But for areas like basements where you have excess humidity, oftentimes picking up a dehumidifier may be necessary. Otherwise, you'd have to let your air conditioner run so long, your house would be uncomfortably cold before you would reach healthy humidity levels. So it's been about an hour only since we plugged these things in. The humidity level is still pretty similar. That one's showing 69, that one's showing 62. This one just went through a defrost. And I think all that means is it turns off the compressor for a couple minutes. So we reset the breaker. Apparently we had been plugged into the same circuit with a little electric heater that we had plugged in. Thankfully, these things actually just went right back into the operation modes that we had set on them, which is good to know. We're gonna pull out these bins and just see if there is any water accumulation in them yet. It's only been like an hour and a half or something. So we'll start with the Arctic King. And you can see in here, we have a little bit of accumulation down in there. We are making progress, so that one's for sure working anyway. All right, this one, I can hear water down in there. There is a little bit of water down in there. So this one is also working. Now the low ambient temperature in here of a little over 40 degrees, 41 degrees, I think is giving the old one kind of a hard time, so it's kind of at a disadvantage. These tubes are all getting frosted up, which it's actually fairly common for them to do this. It is accumulating moisture, however, the moisture is not able to drop down into the pan underneath. So if we pull this out, there's not a whole lot in there, but there is a little. All right, well, we will leave these guys alone and let them operate. We're gonna go through and talk about several different things that are in this PDF document that ASHRAE released. I'll actually link to it in the description of this video, but it's got a bunch of useful information in there, just kind of talking about all of the main things that humidity levels affect in a given building. They have this chart that we'll start by looking at, and you can see that there are a bunch of different things that taper off in either direction as humidity goes lower or higher. As the air gets drier, that actually increases survivability for some types of viruses that actually get worse as it gets drier. For some reason, I thought if the air is drier, it's just gonna make it harder for everything to survive, but apparently it actually makes it better for some things, which is super interesting. And then the same thing is true as it gets more humid. That definitely allows fungi and mold and lots of different things to happen that wouldn't if it was in that optimal humidity range. And as you can see, that range is from 30% to 60%, with 50% kind of being the sweet spot between all of those different hazards as they taper off. You even have building material off-gassing that happens where that humidity will interact and release chemicals that you really don't want to be coming in contact with. So by keeping the humidity below that threshold, that's going to reduce that significantly. If you look kind of where they all taper to, 50% appears to be kind of the sweet spot for your relative humidity, where those things are all reduced the most. Now, even though on that chart, 50% appears to be the perfect humidity level, we actually can't always have our building at 50% humidity because sometimes the outside temperature makes it not possible to do so, because it would cause significant damage to the structure of the building if we actually had it at 50% humidity all the time. Most building structures are designed for a humidity level of closer to 30% or maybe even less in extreme temperatures, because otherwise you basically have a bunch of dehumidifiers in your thermal envelope, in the walls, because any cold surface, like a cold piece of wood or a window, anything that's below the dew point of the air is going to collect moisture, and then that moisture is going to run down and get trapped in the building structure. And eventually that will cause rot, mold, mildew, all those sorts of things that are associated with trapped moisture. So you can't over humidify in the winter, which is why 30% is actually closer to the sweet spot for winter humidification. In the summertime for dehumidification, we're actually fine to go with that 50% number because we don't have the same issues with the building structure relating to that condensation issue. All right, it has now been at least 6 hours. You can see we have made significant progress just by the look of how some of the walls are drier. So you can see right here, we've got a pretty significant quantity of water, but definitely a long ways to go before this thing is full. This is a challenge. It was the injection pump. Same story. We're making good progress. And finally, the old one has a few drops of water. It looks like it's actually less than earlier. And that's because it looks like all the moisture is accumulating on those coils and it's not drying, it's not dripping out at all. It's kind of a bummer because it's basically not going to put out any water until this piece of ice gets big enough to where it's no longer able to keep it all below freezing, and then water might start to drip off of it. But yeah, we'll come back tomorrow and see what it's all looking like. Humidity also has an effect on static electricity. When humidity levels are low, when you're walking around on the carpet and then you come in contact with something that's more grounded, which has to be, I think, above 4 kilovolts before you're able to discharge an electrical spark. And so that's 4,000 volts that is built up on your body when you actually feel that electrostatic discharge. But that almost completely goes away once your humidity level is at 45% or above. With that then, like in operating rooms where they're using explosive anesthetics that are highly sensitive to this sort of thing, you don't want to have sparks just coming off of the doctor's fingers. So they maintain humidity levels of 50 or 55% to almost completely eliminate that. That in combination with a grounding system that will almost completely eliminate the possibility of static discharge, but humidity is actually a huge component of that. And finally, one really interesting study that they did is on the mortality of mice when exposed to an aerosolized influenza. When the humidity levels were really low, they almost all died with only 15 minutes of exposure. In that middle range though, they did much better, and then as the humidity level increased, the number significantly increased again. So it just goes to show that having that optimal humidity can make a big difference in the health of the people or mice that are dwelling in a location. So those are several of the reasons why we are paying attention to the humidity levels in our home. Let me know down in the comment section if you guys have other thoughts about humidity or stories about terrible things that have happened from really low or really high humidity. It'd be really interesting to see. It has officially been over 24 hours since we initially started these. So we're going to take a quick look and see what each one is doing. This one right here is still running. So this one is not yet full because it would be hitting that full indicator right there if that were the case. Down over here, the little guy, it says that it has reached full capacity. So that one has a full tank. You can see this one is approaching its maximum capacity, but it's not yet there. Now this guy, this is what I'm excited to see. Oh man, look at that. It's one solid brick of ice. And even less moisture than yesterday. So actually what we'll do, we'll unplug this thing. Actually, we'll just turn it off using our switch in this case. And we'll maybe put a little heater on the back of this and let it drip out. So in about 24 hours, we have dropped the humidity in here significantly. The humidity level right now is at 57% according to this unit. That's a pretty significant reduction down from, what was it? 80? Almost 80% initially. Obviously this basement has issues where there's continual moisture coming in through the walls, so you can see that that's all still wet right there. There's plenty of things that need to be addressed with the way this foundation is exhibiting some undesirable qualities. All right, let's take a look at our energy usage. Here's our old Amana one. It's used a total of 3.69 kilowatt hours. The Arctic King used a total of 1.89 kilowatt hours. And the Cooper and Hunter used a total of 4.26 kilowatt hours. It's time to quantify how much water each one has produced. We were able to manually defrost this by using an electric heater, so now we can measure how much water this thing was able to produce, basically by just accumulating it in the form of ice, since it doesn't have a proper defrost mode. All right, so here we go. Okay, that's 2 cups. And so that's 1 1/4. So 3 1/4 cups, 3.25 cups. All right, now we'll go over to our Arctic King. So 13 cups for the Arctic King, which is actually the maximum quantity that this thing is able to hold in its bin, because it did have the bin full light on. Instead of manually pulling out the tank and measuring it like a caveman, we are going to actually use the pump that is integrated into this thing. On the back of it right here, we have a port down in this bottom corner that will allow us to attach a piece of tubing to it. I think we're ready to go already. I just have to turn it on. Ready?
All right.
I have to read the instructions. We read the instructions, and what we have to do in order for this pump to work is actually wait until the tank is all the way full. What we did in order to make it work is we've taped this float switch up so it should read as if the tank is full. So we'll put this back in here again now. Right here on top, you can see that the full light did come on. So we should be ready to pump. So we'll get the hose ready to go, and then we will measure how much this thing put out. All right, we're gonna hit the pump button and it should start to pump. We'll see what happens here. Oh, I feel it. There it goes.
Nice. Okay.
It's just not very fast. So, well, I'm afraid that we might have to do this a different way. 1 cup. The Cooper and Hunter was able to produce 36 cups of water for the amount of electricity that it used, and we had to now do the math on that. So we're going to do the math and come back in just a minute and tell you guys what the final numbers are like. All right, we've got the final numbers. Starting with the Amana, it used 6.27 kilowatt hours over the roughly 30 hours that these things were plugged in. And it was able to produce a total of 3.25 cups of water. So if we take our number of cups divided by the number of kilowatt hours, that comes out to a whopping 0.51 cups per kilowatt hour that this was able to produce. Right over here, the Arctic King used a total of 3.79 kilowatt hours. So it used roughly half, a little more than half of what the old Amana used, but it was able to put out 13 cups of water compared to the 3.25 that one was able to produce. So our efficiency ratio for the Arctic King is 3.43 cups per kilowatt hour. Pretty massive compared to the 0.51 cups that the Amana was able to produce. And finally, that brings us to the Cooper and Hunter. So with this unit, it ran pretty much the entire duration of the test. The bucket was almost full, so it used a total of 7.22 kilowatt hours. So definitely used more than all 3 of these units, although not that much more than the 6.27 that the Amana used. But that 7.22 kilowatt hours gave us 36 cups of water. So if we do the math on that, that comes out to be 4.98 cups per kilowatt hour, which beats out the Arctic King, and it just slightly beats the Amana as well. So kind of interesting numbers to keep in mind. These things were fairly comparable. The percentage difference, 3.43 to 4.98. So you're getting an extra 1.5 cups of water per kilowatt hour with the Cooper and Hunter over the Arctic King. Josh, you can throw the percentage up on the screen. That's a pretty significant difference in efficiency from that 3.43 cups per kilowatt hour with the Arctic King to the 4.98 cups per kilowatt hour for the Cooper and Hunter. So the results speak for themselves. Investing in a high quality dehumidifier is probably a good idea. So I will link to this particular dehumidifier in the description underneath this video. If you guys enjoyed this content, take a second, hit the thumbs up button. It helps the YouTube algorithm to know to share this to more people to hopefully be able to help them with their decisions regarding dehumidifiers as well. We have numbers from 2 more locations that we shot after the fact, and those numbers will be here on the screen. We actually took the Amana and the Arctic King over to Ruben's place just to retest those in a higher ambient temperature of closer to like 65 degrees or so. And it actually made a pretty big difference. As you can see, the Amana was able to more than double its output, and the Arctic King was like an extra half a cup per kilowatt hour compared to the lower ambient temperature. So higher ambient temperatures or more normal ambient temperature definitely makes a difference in helping them to be slightly more efficient. And then finally, we tested in a third location with a totally different dehumidifier made by Danby that's probably about 10 years old or so. And that one was able to be semi-efficient at about 2.5 cups per kilowatt hour, but that's still half of the efficiency of the Cooper and Hunter. If you have a basement where you're going to be running a dehumidifier all of the time, I would highly recommend investing in one that has a really good output. Otherwise, you're really just throwing a lot of money at potentially not a lot of water extraction like the Amana. I'll show you a little bit of the bonus footage from Ruben's basement if you guys stick around a little bit longer. But otherwise, thank you guys for watching. Again, our top recommendations for dehumidifiers are in the description below. And we will talk to you guys in the comment section and hopefully the next video as well. See ya. So there's a second chance for the Amana to hopefully produce more water per kilowatt hour. Hopefully this thing is going to be a lot less likely to freeze up. All right, well, the verdict is in. We did the math on it, and this unit was only about 25% of the efficiency of that unit. So are you going to keep your
Yeah, probably we'll put a link in the description to my eBay listing of this Amana. If somebody wants to buy it.
So link in the description if you guys would like to purchase a high quality vintage dehumidifier, probably serial number 3, most likely, of the dehumidifiers that were ever made. Where are we today?
A humid basement.
A humid basement. Does it smell good down here?
No.
What does it smell
Smells like pee.
What? So what does it smell like down here?
Funny.
High five. And tell everyone thanks so much for watching and to please subscribe.
Thanks for everyone for watching and please subscribe.
That's right.